So converting these radicals from a whole radical or entire radical to a mixed radical, what we want to do is factor this. We want to factor out the perfect square of 25 times 5. Okay, once we have the perfect square, we're going to square root that. So square root of 25 is 5, and then the 5 is left in the square root. Okay, so same thing here. We want to identify the perfect square factor involved here. So it looks like the perfect square factor, I can divide by 4. Okay, if I divide by 4, I get 27. Okay, so I'm just going to start writing out the perfect square factors here. So 4. Okay, and then dividing that by 4, what do we get? 52. Yeah, so we get 52. So then I can divide 52 by 4 again. So I'm going to end up with 4 times 4. And 52 factors to 4 times 13. Okay, and then we have a squared times a. Okay, so those are, we've now factored out the perfect square factors. Now, if you recognize that that's divisible by 16, that's perfectly fine. But those are perfect square factors inside the square root. So now those come out. So we end up with 4 squared and 4 squared. 2 squared and 2 squared. So I'm just going to write this as 2 times 2. The a comes on the outside as a, and what's left inside is going to be 13 times a. Okay, so I'll just highlight those parts are the perfect square parts that came out of the radical. So this one here, now we need to find perfect cubes. Okay, it's a cube root. So now we're going the opposite. So what we're going to need to do is we're going to express 3 inside a cube root. Okay, so what I'm going to do is I'm going to cube root it, but I can't just cube root 3 because that's different than 3. What I'll do is cube root to put it underneath the cube. Cube root. So to put it underneath the cube root, and then I need to cube it to balance it. Okay, so these are going to undo each other. So if I were to work out this number, this would just work out to be 3. And then I've now expressed the 3 inside the cube root. And there's our cube root 4. Okay, so again, I'll highlight the parts that go together. That really cube root of 3 cubed is really the 3 that I started off with here. Now, once it's inside the radical, I can just write it all inside the same radical. So 3 cubed is 27 times 4. Okay, and again, I'll highlight the 27. The 27 really is the 3 cubed. And then I can express this as a whole radical. This becomes the cube root of 4 times 27, which is 108. Okay, so there's a whole radical. So these first 2 examples are going from whole or entire radical to mixed radical. This is going from a mixed radical to a whole radical. So if I want to order these, okay, what I can do is I can put these inside the root. So these are all square roots. So if I can more easily compare these if I know what the whole radical is going to be here. So this is 208. When I write that as a whole radical, it's going to be 2 squared times 50. So it becomes square root 200. This is going to be 7 squared times 4. So I'm going to put that inside. So 7 squared is 49 times 4 is 196. Okay, the 3 is square root 360, stays the same. This is going to be same as 5 squared times 9. So 5 squared is 25. Okay, times 9 is 225. So now that these are written as whole radicals, it's going to be much easier to order. So I know that square root 196 is first. That's the smallest, square root 200. Square root 208, square root 225, and square root 360 is going to be the largest. Okay, so if I were to do this with technology, what I could do is actually I can just put these in my calculator. Okay, and then I can place them on a line, then place them on a number line. So I'll put them on a whole number line. Okay, and we can see exactly what the whole parts and the decimal parts are, and so we can see what they look like on a number line. So for adding and subtracting, we need like radicals, which means that we need to have the index the same, and we need to have the inside part of the radicals the same. Now to do that, we really need to have the simplified form of the mixed radical. So here I need to first of all factor out the perfect squares. So here's a 36, here's a perfect square of 25, and so when we work that out, that's going to be square root of 36 root 2 plus square root of 25 root 2. Now at this point I need to check, are these like radicals? In fact they are. This square root 2 is the same as this square root 2. These are coefficients, so these are actually counting the number of root 2's. So I have 6 groups of root 2 here, 6 groups of root 2 here, so I have 11 groups in total. So I just add those up and say I have 11 root 2, or 11 groups of root 2. So I would need to do the same thing here. I need to identify perfect cubes. So we need to start knowing our cubes and perfect squares. So our perfect cubes are going to be, I'm just list them out here. Over here, I'm going to have 1, 2 cubed, 3 cubed, 4 cubed, 5 cubed. Okay, and I just go dot, 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 like that. We probably don't need to get too high into the cubes, but we really should know the first few. And when I look at 135, 135 is divisible by 27. Okay, so when I write this out, I can write this as 3 cube root 27 times 5. So I need to identify my perfect cube factor in there. Okay, so then I need to look at this group and say, well, what does 320, what is 320 divisible by? Well, it's divisible by 8. However, it's also divisible by 64. So I'm going to write this as 64 times 5. Okay, so 64 times 5 is 320. Now I can take the perfect cubes out of the radicals. Okay, so I end up with 3, and I'm left with cube root of 5. And again, just so that we can see, that cube root 27 becomes this 3 here. So here we're going to cube root 64. That's going to be 4 cubed. Okay, so cube root of 64 is 4, and then we're just left with the 5 inside. And again, so that we can see that 64, cube root 64, becomes just the 4. Once we've got into mixed radical form, we can see, oh yeah, we have like radicals. The indexes match, the insides of the radicals match, so we're counting the same thing here. So we have 9 cube root 5's, 9 groups of cube root 5. We have 4 groups of the same thing of cube root 5. So if I have 9 groups here and I'm taking away 4 groups of the same thing, I'm talking about it's 5 groups then. So I have 5 groups left over. Okay, so there's my final answer.